Alright guys, so today we're going to be talking about factoring second degree polynomials. Quick reminder, a second degree polynomial is going to be any polynomial where the highest exponent is to the second power. So we're going to talk about three things. First is simple factoring, where that leading coefficient, that a, is going to be equal to 1. You guys have done that before, pretty easy. The second one will be what do we do when that leading coefficient a is not 1, but it can divide out of both the other two. We call it a divisible leading coefficient. Not quite as easy, but it's still pretty easy. Should be review, but we'll go over that as well. Third, we'll look at what do we do when that a in front won't divide evenly into b or c. Now we call it an indivisible leading coefficient, and for that we have to use something that we call the Berry method. So let's jump into it. The first example that we're going to look at is one of our nice simple leading coefficient of 1, and all we have to do here is we are going to take our constant and we're going to find two numbers that will multiply to get our constant, and we'll add to our number in the middle there. So here we're going to find two numbers that will multiply to -4 but add to 3. Now I'm just going to go ahead and tell you what that is. So that's going to be -1 and 4. And if you do a quick check, -1 plus 4 will give you 3. So that's going to work for us. So then all you have to do is write down two what we call linear factors. Linear meaning it's an x with no exponent. So x and x. And we'll just plug in our factors of -4. So we'll have x minus 1 and x plus 4. And that's it for that one. Pretty easy, pretty simple. You could check from there if you wanted to, but you guys should have that one, so I'm not going to waste our time there. Now the second guy is also fairly simple, but it's just a little bit more difficult. Kind of has a little twist to it. So if we look at our leading coefficient here, we have a 3. Now that 3, if you take just a second to think about it, will divide evenly to all three of our terms here. So all we're going to do is just divide it out. But we can't just delete it. It has to go somewhere. So what we're going to do is we're going to push it out front here. And then we'll put in parentheses next to it whatever's left over once we divide the 3 out. So 3x squared divided by 3 is a simple x squared. 9x divided by 3 is 3x, and -12 divided by 3 is -4. Now, as you guys know, I'm notorious for being lazy, so what I did was I cheated a little bit, and I picked one that would, once we remove the leading coefficient, would take us back to the example we just did. So, no real new math needed to do here, because we know that this factors into these two. So all we have to do is keep our 3 and replace our trinomial with this pair of linear factors here. So we'll have 3 times x minus 1 and x plus 4. And that's it for that one. We are all done. So again, pretty much review, something you guys have seen before. Shouldn't be too terribly difficult. But now we're going to move to the new stuff. So the new thing we're going to be looking at is what do we do if our leading coefficient will not divide evenly into our other terms. So here I picked one where our leading coefficient is 2, and our leading coefficient will divide into this -12, but it's not going to divide into the 5. So we don't want to do that because we'll have 2.5, and we'll be left with the struggle of trying to find two numbers that will add to -6, or sorry, multiply to -6, but add to 2.5, which is going to be a terrible pain. So instead of doing that, we're going to do a bit of trickery here. So we call this trickery the Berry method. Now there's an actual mathematically sound reason as to why this works, and I may make a video explaining that, but for now I'm going to ask you just to trust me here. But realize this is just a trick. So don't go trying to use this in other things. It's not going to work out well for you, but for now you can use this trick. So what we'll do is we will take our leading coefficient, and we don't want to multiply it by the whole trinomial, but we do want to take that guy and multiply it by our constant on the end. So now negative 12, when it's multiplied by 2, will now be a negative 24. Now, right here, right now, before you go any further, stop and make a note, because what we did was just illegal. So whatever our answer is going to be, because we multiplied this by 2 down here, it's going to be wrong by 2. So make a note of that so you don't forget. And now what we're going to do is we're going to pretend like this was our trinomial with a negative 24 instead of negative 12, and we'll try and find two numbers that will multiply to negative 24 but add to 5. So I'll make our little table here, and once again I already have the factors, so instead of wasting our time I'm just going to go ahead and pull them out. So what we have here is we're going to use negative 3 and 8. And a quick check, negative 3 plus 8 does in fact give us 5. So now this is where our trick is going to continue. It's going to get a little bit weird. So now we're going to make two linear factors here again, except now instead of it just being an x in each linear factor, we're going to do whatever our coefficient was times x. So we're going to have two linear factors, one 2x, and then we'll plug in our factor there of negative 24, and the other one 2x, and we'll plug in our factor. Now our factors for negative 24 were negative 3 and a positive 8, so we'll go ahead and fill those in. So everything we did there was a trick. So now what we have to do is we have to undo that trick, and this is where this piece of information here comes in handy, because what we said was that our answer that we come up with is going to be wrong by a factor of 2, so we have to figure out a way to get rid of that. And so here's what we're going to do. We're going to look at each of our linear factors here, and we're going to try and find a number that we could divide out of them evenly. So for example, we'll look at this guy and we say, okay, 2x and negative 3, is there anything I can pull out of both of those terms? Now obviously not, because they're both prime, so we'll move to the next one, and we'll say 2x plus 8, and we'll try and find a number we could pull out of both of those. Now this one's pretty easy. They're both divisible by 2, so I'll go ahead and divide out of 2. So on our next step, we'll keep this factor the same. It'll still be 2x minus 3. But now here we're going to pull that 2 out and put it outside, and write down what we have left. So now we'll have 2x divided by 2 is just x, and a positive 8 divided by 2 is just a positive 4. Okay. So now we found our 2, we have to get rid of it. So the nice easy thing for us to do here, again because we're doing a trick and we don't have to worry about balancing anything, is we're just going to divide that whole piece by 2. And now these guys will cancel out, and we'll be left with 2x minus 3 and x plus 4 for our two linear factors there. Now I can tell you right now we are done. That is your answer. You don't have to go any further. We're totally good, except if we're going to be good mathematicians here, we're going to check our answer to make sure we didn't goof up somewhere. So we're just going to factor that back out and check it. So 2x times x will give us a 2x squared. 2x times 4 will give us a positive 8x. Negative 3 times x will give us a negative 3x, and negative 3 times 4 will give us a negative 12. So now if we just do a little of combining like terms, we'll get that we have 2x squared. This guy, 8x minus 3x, that gives us a positive 5x minus 12. And that is exactly what we started with. So our factoring was correct, and this would be your answer right here. So that's one example, nice easy one, but I'll show you one more just so you can kind of get the hang of this and see a case that's maybe not quite as simple. So again, we'll start by checking with this guy here. We have 10x squared plus 13x minus 3, and we'll look at our leading coefficient of 10 and try and decide if they'll divide into our other coefficients, but obviously it's not going to happen. So what we'll do is we'll go straight on with the Berry method, and we will multiply our 10 times our negative 3, making that a negative 30. Now again, make a note. because we multiply the 10 in, whatever we have will be wrong by 10. And from here, we'll try and find two numbers that will multiply to negative 30, and we'll add to 13. So, surprise, surprise, I already have those factors, and I'm just going to hand them to you for the sake of time here. And so we'll have negative 30, and we're going to factor that into negative 2 and 15. And a quick addition check here, negative 2 plus 15 will give us 13, so that's going to work. And so just like before, we'll write down our two linear factors here, leaving in our 10. So we'll have 10x and 10x, and we'll plug in our factors for negative 30. So 10x minus 2 and 10x plus 15. And we'll go back to the same game we played before of trying to remove a common term from each linear factor. Now this guy here, we have a 10x and a negative 2, so an easy common term there is 2. So we'll divide that out and go that we have 2 times and then whatever's left. So 10x divided by 2 is 5x, and negative 2 divided by 2 is a negative 1. And then over here we'll do the exact same thing, and we'll go, okay, so these are both divisible by 5. So we'll keep a 5 here, and then we'll divide out what we have left. So 10x divided by 5 is 2x, and 15 divided by 5 is 3. So now, just to kind of clean things up, I'm going to go ahead and put this 2 and 5 together, because we know if we're multiplying a string of things, we can rearrange those things in whatever order that we want to. So we'll take these guys and put them together up front, and so 5 times 2 is 10. So we'll have 10 times 5x minus 1 times 2x plus 3. And now the last step is going to be that we know we were wrong by 10. So we will just divide that whole guy by 10. These cancel out, and we're left with 5x minus 1 times 2x plus 3. Once again, this guy is going to be totally factored, and we are 100% done. However, we're going to check it just to be sure. So 5x times 2x gives us our 10x squared. 5x times 3x gives us a positive 15x. Negative 1 times 2x gives us negative 2x. And negative 1 times 3 gives us negative 3. Quick combining of like terms here, and we get 10x squared plus 13x from these two guys here minus 3. Now we got the answer we started with, so obviously we must have done that correct. So, hope you guys enjoyed the video. If you have any questions, just let me know during class, and I'll cover anything and everything you may have to ask.